Hello, everyone. Today we are going to talk about system design interview. If you like this session, please do subscribe to the Interview Guru channel. Okay, so what is system design interview? System design interviews are getting increasingly common in interviews these days, with most of the top tier companies requiring one or more rounds of it. Hence, it is of extreme importance for candidates preparing for interviews, technical interviews that is, to be fully prepared and have a strategy for system design interviews. And that's exactly what we're going to talk about in this session today. Okay, so without much further ado, let's get started. What we are going to tell you is a 9-step formula on how to tackle these interviews. With this 9-step formula, you should be able to deal with pretty much every system design question that is thrown your way. And also it sort of creates a structure for you, a framework that you can use, a mental model, so to speak, for you to tackle these designed vague questions. So these questions are actually by nature, they're very vague and open-ended. And it's up to you how you structure this and put kind of a framework around it so that the result that you present to your interviewer is a coherent story that shows the depth of your understanding on this particular topic. Okay, so what is this 9-step formula? Step 1, requirements and goals. In this step, you essentially walk through the various requirements, what exactly you expect the system to do, and just to make crystal clear in terms of what the interviewer has in mind for the system to do. Step 2, the back of the envelope estimate. This is very, very important for system design interviews, which are for large scale systems, because that's exactly what the interviewer is looking at. Are you able to make rough estimates of how this system is going to scale, what kind of throughput is going to be there in the system, and is it designed to handle that kind of scale? System API design. Now, this is the next step, and at this point, you are going to present an API for the backend, which essentially will determine how the web or client interface interacts with the backend. You have to define the data model. This is essentially how your entities in the system are related. They're related to each other. It could be a SQL-based data model, or it could be a NoSQL-based data model. We'll get into the details of those shortly. Step 5, data estimation. At this step, you are going to estimate how much data is required for each record to be stored. And this is important because it's sort of like the next extension to your back of the envelope estimate. And this is you're essentially going down to the next level of detail to calculate how much data is required. Next step, you do a high level design. So you basically put the top level big boxes, so to speak. And this gives you an idea about what are the various high level moving parts of your system. Next, you drill down a little bit into the component design. At this step, you are going to identify the basic design of the system and the core components of the system. And next step is essentially enhancing that. So in step 7, you identified the MVP product. And next step is essentially improvements, optimizations, bottlenecks. You are essentially taking it to the next level to scale it to the required level of scale you need. And final step is something that many interviews miss, and that is cross-checking with the requirements. Did you actually manage to meet the requirements that you are set out in the step number 1? So these are the 9 steps that you need to keep in your mind, keep in the back of your mind to tackle any system design interview. Okay, so with that structure in our mind, let's get down to the details of each of these steps. Requirements and goals. What does this step mean? So this is where you're going to interact with your interviewer to identify what does he actually want the system to do. What are the use cases? Who is the customer? So the use cases and the customer will determine how the system is going to behave. And what is the needed from the system? What are the top level, high level goals of the system? So it's very important to keep this thing in mind when you're designing. Now you drill down into the functional and non-functional goals or requirements of the system. It's important to note them down separately, simply because they serve different purposes. The functional goals determines, for example, if you have like a news feed, what are the things you require from the news feed? And in the non-functional goals, you discuss what is the scale you expect the system to work with, and various other non-functional items such as security and so on. So those are the things you're going to talk in that. And you should also discuss with the interviewer what are the out of scope requirements. So just to make absolutely clear the scope of your discussion with the interviewer. If you really think about it, 45 minutes or 1 hour that typically these interviews are for, it's not really enough to even go to any level of detail for any significant system design. So it's very important to set boundaries of what you're going to achieve in that session. Okay, now let's get into the back of the envelope estimates. What are these estimates? So typically you would like to know what is the traffic estimation, essentially the read and write requests per second. This is quite important because this really determines really how many users are interacting with the system, and effectively how many requests are landing on the system in terms of reads and writes. And it will also determine the kind of backend that you need to build. For example, if you are dealing with a system which has got high volume of reads versus writes, you can think about designing the data tier in such a fashion that it's not so important. Consistency is not a high requirement, so to speak. So, or in other words, you are able to trade off consistency against availability. So eventual consistency will be acceptable in such a system where you have large number of reads versus writes. So yeah, so it's very important to get an estimate of the traffic. And the traffic estimation really comes down from your number of users who are the daily active users of the system. And that will help you do the actual traffic estimation in terms of the request per second. So you can sort of do the back of the envelope estimate based on the number of users. And if it is the daily active users, you divide it by the number of seconds in the day, and that will give you an idea about the number of read requests and the number of write requests, and the ratio between the reads and writes will give you that kind of numbers. So that's the number one thing you need to calculate. Again, I would recommend you watch our other videos which are specific to specific design sessions, and that will give you some real world examples of these estimates. The next estimate you would like to do is a storage estimation. Storage is the amount of block storage you need to, or object storage you need to have to store this data for say 3 years or 5 years. So again, the data estimate that you did, or the rough data estimate that you will do will actually feed into this storage estimation. Next to the bandwidth estimation, this is the number of Mbps, megabits per second, in terms of incoming and outgoing traffic. This will give you an idea about the throughput of the system. And finally, the cache estimation. So based on your estimate of your traffic and the amount of storage that is required, say per second or per day, you can actually estimate how much cache you would need to use using 80-20 rule, which is essentially means 80% of your your traffic actually served by 20% of data. So you would like to store this 20% hot data so that the latency is low for these kind of requests. Okay, now let's look at our step number 3, system API design. What does this mean? So essentially at this step, you would like to define, again, at a very high level, the REST style APIs. This will give you an idea about how the system, the backend essentially exposes its interface to the clients. So it's best to define REST style APIs. And you need to consider things like the parameters, the headers, and the return JSON. The next step is to define the data model. Now we get down into the depths of exactly how the entities are related to each other, essentially what kind of tables and associations between the tables you need to have. So this is an example. Say you have an employee and associated with departments. What is the association? What are the different fields? What data type is there? So at least a sort of rough calculation of that will give you an idea about how much data is required to be stored. At this point, you would also like to discuss SQL versus NoSQL in terms of your data model. Again, the decisions are determined based on what kind of application you are building, what kind of consistency model you need, and how we want to split, partition the data across. So those sort of decisions will determine whether you want opting for SQL or NoSQL database, and whether you need to have normalized versus denormalized. Again, that will depend on type of queries you are performing. Typically, normalized tables don't perform well, don't scale well. When you're dealing with large number of users, large number of requests, you would typically like to denormalize this table. But if your table requires high level of consistency, for example, a banking application, then it's extremely important that the data is normalized and consistency is of high importance. Now, next step is to do the data estimation. So essentially, you're calculating the data per row inserted. So again, this the data model that we saw earlier that will help us do this data estimation. And this is essentially just the next level of calculations, the back of the envelope calculations that you did earlier. But now with the knowledge of the data model, you can get much better estimate. Looking at the same data model, you would be able to exactly find out how much data is required per insert into the table. At this point, you can discuss various flows and the data estimation for each of those flows. Now, next step is quite important because at this point, you do the high level design. So this is where you identify the client, the web servers, the platform, the database, the worker services. And at this point, you discuss the various flows. You talk about the caches. This is an example of a high level design. Again, it talks about the different types of clients, the load balancers, the metadata servers, where the data is stored, the cache that is involved. If there's a object storage where you would like to store things like the video files or the picture files, those kind of things are depicted here. But again, it's at a very high level. Now we move to step 7. This is probably the most critical section in terms of your design because this is exactly where you are designing the MVP. So in other words, you're solving the problem that needs to be solved, where you're presenting a solution to the real problem the application needs to solve. So for example, if you're designing a tiny URL service, what exactly do you need to do in terms of the various components to serve this tiny URL website? So the idea is to perfect your design for a single user, get a minimum viable product. And now next step is where you take it to the next level. You talk about improvements, optimizations, and bottlenecks. So at this point, you also discuss scaling. So when you talk about scaling, you essentially identify the single points of failure the load balancers which are there, how do you achieve redundancy, at what points you place the load balancers, at what layers you add the caching layers. Typically, caching can be at the web server tier or the application server tier or the data tier and so on. We talk about the replication. So what does it mean to replicate the data across different data centers or within the data centers to multiple places so that your read throughput or read latency improves. Um, and you talk about other improvements such as message queues, putting async workers into the picture. And you would also like to revisit your SQL versus NoSQL choice at this point and whether it was the right choice. Identify any single points of failure. And this is the final step, but this is a very important step. And this is where you cross-check your requirements. Essentially, the idea is that are all the requirements met? Can future additions be made for additional enhancements? And that is it. So that is our 9-step formula for tackling system design. Hope you liked your presentation. Please follow our channel. Thank you very much.